JWST, the epic telescope, is created to discover and show us the unknown things of the universe. It has already started to make some breakthrough discoveries. Researchers stated that James Webb Telescope will help space research set a benchmark with its discoveries. But how many years would it serve? Would its mission ever come to an end? Would it ever get back to Earth again? So stay tuned as we are going to discuss when does the James Webb Telescope's mission come to an end? Hello everyone, welcome to Space Discoveries. Subscribe to the channel for every single detail about the discoveries in the vastness of space. Also, do not forget to hit that bell icon for new updates. Having said that, let's get started. We, all the creatures on planet Earth, are made out of tiny cells filled with chromosomes. Isn't that amazing? So many mysterious things out there, and we want to know more. But hardly anything is known. It's brainstorming that all the chemical elements came from exploded stars, that everything we see around us was recycled from inside of stars. But what exactly is this recycled star? We set off to measure the Big Bang, and we measured the map of the cosmic microwave background radiation, using millimeter waves, and it's the entire sky wrapped around an oval so you can see it. To date, who knows exactly why the Big Bang happened? But that epic event led to the existence of galaxies, stars, planets, and eventually people. So it turned out to be important. But how did that work? Well, scientists decided to take pictures. So, of course, NASA made the gigantic Hubble Space Telescope to send the space and click pictures of space for us. This picture was taken around 1995, and it shows galaxies far away. So we were thrilled to have this picture, and it shows thousands of galaxies. But they were unable to include the farthest galaxies, though. There are no images of infant galaxies when they were born. We required a bigger and more powerful telescope that could pick up infrared light from the farthest cosmos, which had been stretched out by the universe's expansion, so we had no idea what we'd find. As a result, scientists penned a book requesting that engineers make us an even more powerful telescope, and the historic James Webb Telescope was born. NASA's Hubble Space Telescope is gathering data. To date, with all 4 operational sensors, the team has not noticed any more synchronization message difficulties. Hubble has been gathering groundbreaking scientific observations that have transformed our basic knowledge of the cosmos for almost 31 years. With the Webb Telescope, NASA anticipates that the 2 observatories will collaborate well into the next decade, furthering our understanding of the universe. The James Webb Telescope was also launched with the same philosophy in mind as Hubble's telescope. Simply put, they have no scheduled end date for their employment. They are designed to work non-stop, discovering numerous unknown objects in space and sending photographs of those objects for as long as feasible, as long as it is possible to work without interruption. JWST's unique feature is a massive hexagonal mirror. It has a gold coating that reflects infrared light. It measures 21 feet in diameter. A 5-layer metallized plastic sunshade the size of a tennis court protects it. This telescope is so enormous that it would have to be folded up like origami to fit into a rocket. To be able to imagine and construct this telescope is a remarkable feat of engineering. As a result, we constructed it. Then, on Christmas morning, 2021, we launched it and sent it into space from French Guiana. It was the ideal launch. As a result, the researchers and engineers believe that this fantastic new telescope will provide at least 20 years of operating scientific observations. If we're lucky, it'll keep working for another few years. Going through the tropical clouds operatori's vacuum of deep space took only 2 minutes. So how did that play out in space? The solar panels were initially unfurled by this origami telescope. The transmitter antenna was then unfolded, so that we may converse. It unfurled the panels that keep the large parasol in place. The engineers estimate that it will take around 2 weeks in real life. This is nothing short of a modern engineering marvel. It's also really complex. Is there any way scientists could have done this without this massive telescope? No, was the response. A large telescope is required. It must be in space, and you must practice and backtest it. Third, all orders from here are being carefully unrolled. How could you possibly make something so difficult work? We had to wait many weeks for the fever to drop to a level where we could proceed with the next measures. We send it to a location called Lagrange Point 2, which is nearly 1 million miles away from the Sun. This is a location that rotates with us around the Sun every year, so the telescope never gets any closer. But what do we actually expect during JWST's working tenure? The James Webb Space Telescope is designed to look for light from the universe's first stars and galaxies, which originated after the Big Bang. to investigate the genesis and development of galaxies, to comprehend the genesis of stars and planets, to research planetary systems and life's beginnings. These objectives can be achieved more successfully using near-infrared light rather than visible light. Unlike the Hubble telescope, JWST's equipment will not measure visible or ultraviolet light, but will have a considerably better capability for infrared astronomy. JWST might be used to study the diminishing light of KIC 846-2852, a star found in 2015 that has certain unusual light curve qualities. It will also be able to detect the presence of methane in an exoplanet's atmosphere, allowing astronomers to assess if the methane represents a biosignature. JWST orbits the Sun at the Sun-Earth system's second Lagrange point, L2. An object orbiting the Sun further away than Earth would normally take more than a year to complete. However, around the L2 point, the Earth and Sun's combined gravitational pull allows a spacecraft to orbit the Sun at the same time it takes to orbit the Earth. Staying close to Earth provides for substantially higher data rates for a given antenna size. The telescope takes roughly half a year to complete a halo orbit around the Sun-Earth L2 point. A halo orbit is not an orbit in the traditional sense, because L2 is merely an equilibrium point with no gravitational pull. The spacecraft is really in orbit around the Sun, and the halo orbit may be thought of as a controlled drifting to stay in the neighborhood of the L2 point. This necessitates some station maintenance, roughly 2.5 meters per second per year out of a total budget of 93 meters per second. The observatory's propulsion system is made up of two sets of thrusters. The precise station keeping of the James Webb Space Telescope has been compared to Sisyphus rolling this rock up the gentle slope near the top of the hill. We never wanted to roll over the crest and get away from him. The JWST's thrusters are on the Sun-facing side, so all necessary thrust must be slightly undershot to prevent pushing the telescope over the L2 point, which is irreversible. The James Webb Space Telescope, JWST, is the Hubble Space Telescope's successor, and its major focus is infrared astronomy. The infrared spectrum allows researchers to investigate objects and areas of space that would otherwise be hidden by gas and dust in the visible spectrum. The infrared capabilities of JWST are projected to allow it to see back in time to the formation of the earliest galaxies just a few 100 million years after the Big Bang. With an initial budget of $162.2 million, the Space Telescope Science Institute (STSCI) was chosen as the Science and Operations Center (SNOC) for JWST. STSCI will be in charge of the telescope's scientific operations and data transmission to the astronomical community. The satellite's bandwidth and digital throughput are planned to handle 458 gigabits of data each day for the duration of the mission. JWST has made little progress on its mission so far. After a perfect launch, JWST was freed from the rocket's upper stage 27 minutes later. The solar panel that generates power was deployed 1.5 minutes after the telescope detached from the Ariane rocket's second stage on launch day. The amount of power used exceeded the amount supplied by the solar panels, resulting in significant battery drain. The operating precision of the mirrors is 50 nanometers, which is less than one wavelength of the light that will be measured. The target star HD 84406 was photographed by an IR cam, and all parts of its main mirror were brought into near alignment. Mirror alignment is a 7-phased technique that has been practiced several times using a 1/6 size replica of the telescope. So with a pack of missions scheduled, JWST started its journey in outer space. Noticeably, its mission doesn't include heading back home or termination. It would keep working consistently until the moment it passes out. What do you think of it? Let us know what you think in the comment section. Having said that, that's it for now. Thank you for watching the video. If you liked the video, then don't forget to press that thumbs up button and also that hard red subscribe button as well. We'll see you in the next video. Until then, peace.